Hello, welcome back to Chapter 5, Section 3. In the previous video, the previous example, we talked about solving quadratic equations by graphing, which is actually not what we did. We found the zeros of a quadratic equation by graphing. And I mentioned in that video that we're going to be going back and forth between what's an equation and what's a function and how do we do this. All right. In this video, we're going to introduce the idea of finding the zeros by factoring. All right. Now, factoring is something that came up in Algebra 1. If you were in St. Paul schools and you used this book right here, oh, there's my calculator, then it was actually in Chapter 8. So in class, we would normally practice factoring. And I also have links to my Algebra 1 stuff for factoring. So if your factoring skills are not really up to where they need to be, then you're going to have to review that and you're going to have to practice. It is something that you need to know for us to move on. I'll get you through the problems that we're going to be doing here. But again, you're going to be seeing different types of factoring. And this factoring is not going to go away. We're going to see it again in Chapter 6. And we're going to see it again in some of the other chapters that we're going to come across. And it'll be a big part of the first section, not the first chapter, but it doesn't matter, the first quarter work that you're going to be doing in pre-calculus. And you're going to be seeing it in lots of different places. So factoring is a really, really important skill that you need to make sure that you're very, very good at. Very, very good at. So we'll try to get you through it. So what is factoring actually? What do I mean by factoring? Well, factoring means to kind of unmultiply. What do I mean by that? Unmultiply. All right, so you learned that the opposite of multiplying is dividing. And that's true for the most part, all right? So 3 times 4 equals 12, and 12 divided by 3 equals 4. But it's that by that kind of like separates division from multiplying. If I just said, I want you to factor 12, then you can say, well, it's going to be 1 times 12. That's true. You can also say it's going to be 2 times 6. That's true. You can also say it's going to be 3 times 4. That's true. You can also give me the negative pairs. -1 times -12, -2 times -6, -3 times -4, etc. And that'll be really important as we look into different ways of factoring polynomials. But probably what you learned was to factor it into primes. So what that means is you probably heard it say completely factor. So to completely factor 12, and maybe your teacher did this, you'd start off with one of these. 1 times 12 doesn't really get you anywhere, except, you know, it's true, but it just doesn't, you're still with 12, and 1's always going to be there. You're always going to have factors of 1. So that's one of the reasons why the number 1 itself is considered to not be prime. So we don't use it for our factoring. But let's say I start with 2 times 6. Now 2 is a prime number, but 6 is not. So 6 is going to be 2 times 3. Those are all prime numbers. If I started with 3 times 4, 3 is prime, it's right there, and then 4 would be 2 times 2, that'd be these two. So I'm still going to end up with the same thing, 2 times 2 times 3. And of course, when I teach this in Algebra 1, we talk about whether you use an exponent or not, all that extra stuff that I'm sure that you remember. Okay, so that's the factoring part. And factoring a polynomial it's the same idea, except that with the variables, you just have to do it with different steps. But the idea is still the same. You're unmultiplying to get a polynomial broken into factors. How is that useful? Well, here's how it works, okay? We need to know something about the zero product property. The zero product property says that if I multiply two things, so if I multiply A times B, so those are numbers, all right? but I'm keeping them secret. I'm going to hide out what those numbers are. You don't know what the A is, what the B is. But if I tell you that A times B equals 0, now you have more information. Because the only way to multiply and get 0, where 0 is the product, the answer when you multiply, is if you multiply by 0. So this means either A equals 0 or B equals 0, or even sometimes both. 0 times 0 equals 0. So if you know that the product is 0, then that means one of the factors has to be 0. And that helps us find, drumroll, the zeros of the polynomial. All right, so let's do a couple of examples. And again, this is Algebra 1 factoring. We're going to find the zeros of each function by factoring. Now, the zeros are where the graph crosses the x-axis. The equation of the x-axis, I'm going to put it all up here, the x-axis. The equation of the x-axis is y equals 0. Or that's where the function f of x equals 0. So each time I'm going to let that equal 0. I'm going to let that equal 0. These are all going to get replaced by 0. Then I'm going to factor. I'm going to show you what's going to happen. So watch this first one. So I want to find out where the entire function equals 0. And actually I pointed that, but what I really mean is this. This is going to equal 0. So I'm going to write x to the second power subtract 8x plus 12 equals 0. Where does this function equal 0? It's going to happen on the x-axis. How do I solve it by factoring? Well, this is a trinomial, and factoring trinomial shows up in section 8, chapter 8, section 3. What two numbers multiply to give 12? But when I add those two numbers, I get negative 8. So that's going to be x subtract 2 times x subtract 6. And there are lots of ways that we learn how to factor and we learn how to multiply. You are probably aware of multiplying, calling it FOIL. I'm not a big fan of that, I'll admit it. I like the multiplication chart, some people call it the box. It's a much better, in my mind, visual way. And in my experience, I think students usually do better with it. But that's if I multiply. I'm doing the opposite of that. So if you are comfortable with FOIL, this is x times x, which is x squared. This is x times negative 6, negative 6x, and negative 2x. Those are like terms, so I'm going to add and get negative 8x. And negative 2 times negative 6 equals positive 12. So if I go from here up to here, that's multiplying. And if I go from here down to here, that's factoring. And again, this is an Algebra 1 skill. So, a lot of times this means we're finished, but it's not. Sorry, a lot of times students think it means we're finished, but we are not. I want to be very clear about that. You have to do two more things. X subtract 2 could equal 0, or x subtract 6 could equal 0. So either this equals 0 or this equals 0, because if this times this equals 0, one of these has to be 0. Now this again, pre-algebra, maybe Algebra 1 skill. I'm going to add 2, and I get x equals 2. I'm going to add 6 to both sides, and I'm going to get x equals 6. And I can go and check both of these to see if this equals 0. 2 to the second power is 4. 8 times 4 is 32. Sorry, I said 4. 8 times 2 is 16. So you got 4 plus 12, which is 16. Subtract 16, which equals 0. If I put 2 in for x, I get 0. For 6, 6 to the second power is 36. 8 times 6 is 48. 36 plus 12 is 48. 48 subtract 48 is going to be 0. So these are the two x values that make this 0. And we were able to figure that out by factoring. Let's look at the second problem. So I'm going to write 3x squared plus 12x equals 0. Now you're probably thinking, this is not a trinomial. How do I factor this if it's not a trinomial? Well, you're right. You can try it by doing 3x squared plus 12x plus 0 equals 0 for that last term. And remember when we talked about a, b, and c? So the a is 3, the b is 12, the c would be 0, the hidden 0. But this is where we're going to factor by something called the GCF, the greatest common factor. This is 3 times x. And normally I don't write this, but I'll do it because I want you to see it. This is 3 times x plus, and 12, I did that on the previous page. 2 times 3 times x. I'm looking for a common factor. They both have a 3, and they both have an x, and that's it. So to factor by the greatest common factor, I get 3x times x plus 2 times 2 is 4, and that equals 0. Now again, after that first step, so many students want to just call it quits. You said by factoring, I factored it, but it actually says find the zeros, which is allowing me to solve this equation actually. So I do 3x equals 0, or x plus 4 equals 0. If 3x equals 0, that means x equals 0. And of course, check it. 3 times 0 squared plus 12 times 0, 0 plus 0 equals 0. If x plus 4 equals 0, I'm going to subtract 4, and I get x equals negative 4. So let's check that. Negative 4 squared is 16. 3 times 16 is 48. 12 times negative 4 is negative 48. 48 plus negative 48 is going to equal 0. All right. I'll pick up the speed a little bit for these two problems. I get x squared, subtract 5x, subtract 6 equals 0. This is a trinomial. I have all three terms. What two numbers multiply to give negative 6, but add to give negative 5? That would be x subtract 6, x plus 1. And we can check it. 1x plus negative 6x is negative 5x. And of course, negative 6 times positive 1 equals negative 6. So I know x subtract 6 could equal 0, or whatever x is plus 1 could equal 0. Do a little bit of pre-algebra here, and I get x equals 6, or I get x equals negative 1. And you can check both of those in here in the original function to see if you get a 0. Let's do one more. This again has a common factor. So I have x squared subtract 8x equals 0. My common factor is just x. This is x times x subtract 8. So that tells me either x equals 0, that one, or x minus 8 equals 0, and x equals 8. Okay, we will be doing more with factoring as we go.